Audio Jungle. Audio Jungle.
We'll go for the source flow. That theory of source flow was done in last lecture. Today we'll talk about the mathematical model. If I say source flow, so that means suppose this is what source, and from the source the flow is what coming out. The flow is what coming out like this. The flow is what coming out like this. Right. Okay. Here it is nothing but source flow. Source flow, right? Now you can see here the strength of source like last class I had explained. The strength of source is nothing but discharge per unit depth. So basically discharge is nothing but Q divided by discharge per unit depth divided by depth. Okay, or that also can call it volume flow per unit depth, because discharge is nothing but what? It's a volume flow rate. Volume flow rate per unit depth, and it is denoted by small q. It is denoted by small q basically. Okay, so now onward, if you see what is the discharge formula. Discharge, so discharge is nothing but, see here, discharge is nothing but area velocity. Okay, area into velocity. What is the velocity then? Discharge by area. Okay, now if you see here, suppose this is what source, and depth will be given like this. This is the depth we had considered unit depth, na? We have considered unit depth, yes or no? We have considered unit depth. Now what is the mean of it? If this is what source, just listen carefully, you will understand. So just say the radius is nothing but r here. This is suppose source, and radius is nothing but r here. So if you break this, then you will get surface like this. Okay, and what is the total length then once you break this? So you will have 2 pi r. This is the length. Okay, this is the length, and this length is nothing but, obviously it's a circumference. It's a circumference, right? It's a circumference. Now what is the volume? Volume is nothing but area into depth. What is the area you have here? It's a 2 pi r, and depth is nothing but unit depth. So automatically you got volume is nothing but 2 pi r. What is the r? R is the radius of source, right? Radius of source. What is the small r? Small r is nothing but radius of source. All right. Now it's very clear. It's very clear. If you talk about the velocity, velocity which is nothing but discharge divided by area. Discharge is nothing but velocity is nothing but discharge by area. Okay. So also here, as I have explained, the strength of source is defined as the volume flow rate per unit depth. Yes or no? Volume flow rate per unit depth. This is the strength of source, and it is denoted by small q. Onward now you need to remember. So what is the velocity? See, what is the velocity now? Check. The velocity is, it's a discharge, and see, strength of source is defined at the volume flow rate. So discharge is nothing but basically volume flow rate. Okay, volume flow rate per unit depth. Per unit depth. So can I say this discharge, which is nothing but q by area? Okay, this is the volume flow rate per unit depth. Volume flow rate per unit depth, right? So because this q divided by area, and if you check, depth is nothing but 1. What is the depth you have considered? It is unit depth. So also you can call it, this is nothing but discharge, which is volume flow rate per unit depth, means q divided by, you can write depth divided by area. Okay, you can write like this. Okay, you can write like this. This is what area. So this discharge by depth, that is nothing but volume flow rate per unit depth, and this volume flow rate per unit depth is nothing but denoted by q, means q divided by area. Okay. Anyway, now coming to this velocity, if you see here, what is the volume flow rate? That is q discharge by depth divided by area. What is the area you have calculated? It is 2 pi r. Okay. So basically, this is the final result we got, and for single marks question, they can ask to you, what is the velocity here you got? Velocity is nothing but q divided by 2 pi r. Always remember this velocity, because this is for radial flow. Whatever I have derived here, this is for radial flow. Okay. Now the point is, what is this velocity? So this velocity, because for the radial flow only radial velocity will exist, that means radial velocity is not 0, and tangential velocity is what? 0. So what is the v? Resultant velocity. Vr means resultant velocity. Resultant velocity. What is the Vr? I can write this Vr is nothing but v, and this v is nothing but Vr, because v theta is 0. What is the Vr here? See, what is the Vr now? You can check by your own. The Vr is nothing but Q upon 2 pi r. This is very important result. Finally, we got VR is Q upon 2 pi r. This is very important result, okay, for the source flow. This is the radial velocity. huh? This is very important. So for source flow, for source flow, for source flow, the radial velocity VR is directly proportional to Q. What is the Q? Q is nothing but volume flow rate per unit depth. Okay, this is the point one. Second point, VR is also inversely proportional to radial distance, that is 1 by r. Okay, that means reciprocal to radial distance. Reciprocal to radial distance. This is for the source. For sink, the same thing will have a VR, but here it will be minus Q upon 2 pi r. Last class only I had explained source and sink both will be same by magnitude, but just opposite by the sign, because one is inward flow, another is outward flow. Na? So for sink, instead of plus Q, it should be minus Q, that is sink. Okay, that's the only difference. Rest everything is what same. Now coming to the source, or maybe it is sink, maybe source or sink, doesn't matter. Okay, this is what sink. In both cases, the same. If you take the radial velocity, suppose here we have a radial velocity with respect to r. This is r, okay, r2, and this is what, here r1. Okay, this is the VR1, and here up to here this is what, VR2. Always remember, for single marks, VR1 into VR2, this product, okay, means R1 by R2 radial distance is nothing but VR2 by VR1. This you need to remember. This will work for single marks question, and it is for radial flow. This is for radial flow, okay. If I say radial flow, then meaning will be same, doesn't matter, it is source and it is what, sink. Okay, but meaning will be same for both. Always remember, dear. This is the one part, but story is not end of here. What we have to perform now, we have to perform the equation of stream function and equation of potential function for the source as well as sink. For anyone, means for source, if I will calculate, the same thing will be for sink, only minus sign. That Q will be replaced by minus Q for the sink. So anyone we can take, source will take and will derive all the equations, and sink directly we can write. Okay, so now equation of suppose potential function, and we are going to calculate this potential function for source. Okay, and as I told you, for the sink directly we can write. So for source we are going to write. All right. What is the potential function? Because here if you check, radial velocity will have, so now the potential function we have to write in terms of the polar form. Okay, if you remember polar form, what was the polar form? Radial velocity I had shown you, it was dou phi by dou r. Okay, and what was the v theta? V theta was 1 upon r dou phi by dou. So if I say radial flow, so this tangential velocity v theta will be 0. This will be 0 for radial flow, right? Radial flow means that source and sink. So for radial flow v theta will be 0, and for radial flow vr you have taken as, vr is nothing but you can consider as v. It's your choice. You can write vr or you can directly write v. That meaning will be same. Okay, it's your choice. All right. Now coming to the vr, so we can write here. See, this value will be focus. Now vr is nothing but dou phi by dou r. Okay, what is the vr value? Just now you had written vr is nothing but q upon 2 pi r. Just now you have derived, right? Somewhere here, see, just now here you have derived q upon 2 pi r is equal to, and radial velocity, it's a dou phi by dou r. Okay, now so directly you can write dou phi by dou r is equal to q upon 2 pi r, or what you can write, or you can write d phi. Huh? You can write q upon 2 pi r into dr. We can write like this. See, dou you can write in terms of d, that is total derivative d phi. So if you check this and if you want to integrate this, so what will be d phi? It's q upon 2 pi r dr, q upon 2 pi you can take common, it's dr by r. This is nothing but d phi. All right. Once you integrate it, then what you will get? Phi is equal to q upon 2 pi dr by r, integration is nothing but ln r. This is what potential function, and this is very important result. Okay, this is very important result. Now if you see, because r is the radial velocity, and you also know if you want to convert this radial velocity in Cartesian format, so for the Cartesian format, if this is r, see, this is the radial velocity r. So in Cartesian coordinate, this will be x-axis, and obviously angle will be theta, and this will be y-axis. What is x? R cos theta. What is y? It's a r sin theta. What is r square sin square theta plus r square cos square theta? It's nothing but you can write x square plus y square. Yes or no? So x square plus y square is equal to r square, that you know. What is r? R is nothing but x square plus y square. Agree? Now you just keep this r value here. So what you will get? Phi is equal to q upon 2 pi ln r. If you write in terms of x and y, then what you will get? It's nothing but q upon 2 pi ln r. What is the r? It's x square plus y square. Agree? That is the, so basically if you check, this is the equation of x square plus y square. Okay, x square plus y square is equal to, that radius x square plus y square. If you check this equation, this is what? This is the equation of circle. Equation of circle. Equation of circle. Right? There is no doubt. Anyway, so my point is, you got phi here, that is potential function, and potential function, if you check, it is q upon 2 pi ln r. That also you can write q upon 2 pi ln r is nothing but x square plus y square in root. You just remember this equation. This is very powerful. Okay, sometimes question will be asked based on this. So this is the potential function for the source flow. Now we'll go for the calculation pattern. Later on we'll draw, or here also you can draw. There is no issue because it's a radius. R is nothing but radius. So with different radius, we can draw the flow pattern. If you draw the flow pattern, so it's a circle, something like this. R1, R2, sorry. Something like this. This is the pattern of the potential flow for the, so this is a complete circle. I'm not able to draw. This is the complete circle, something like this. Okay, so if you check, this will be for different radius. This will be the phi 1, this will be the phi 2, this will be the phi 3, this will be the phi 4. If you check, phi is directly proportional to r. So r1 phi 1, okay, phi 2 r2, phi 3 r3, means radius you have, because q by 2 pi is what? Constant. Once you change the radius, you will get different circle. So basically, if you see the node point is what is the node point here for the potential function? So for the source flow, for, listen carefully, for source flow as well as sink flow, for source flow or even the sink flow also, potential lines are, these are the potential lines, right? Equipotential lines. So potential lines are circle. This is for single marks. They can ask question. They can say, for the source flow, potential lines are square, potential lines are cube, potential lines are, parabola, potential lines are circle. What is the correct answer? For the source flow, potential lines are circle. It is proved clearly. It is proved. Okay, you need to remember this. This is very important point. If I'm saying this, it means, doesn't mean it's only for GATE. I told you, for any one day exam, maybe you are writing XC GATE also, maybe writing any one day PSU exam. Okay, so this type of question, single marks technical question, they will ask. Okay, so always remember. So this is all about potential flow. Now we have to go for the a stream function. The same thing we have to derive. Similar way we have to derive for the source flow. We have to derive a stream function. Okay, so we can write here equation of stream function. Now you need to write your standard equation as I told you, because it's a radial flow. So we will have only radial velocity. What is the radial velocity? If you write, then its radial velocity is nothing but 1 by r dou psi by dou theta. And obviously v theta is nothing but minus dou psi by dou r. But this value will be 0, because for the radial flow, tangential velocity will be 0. For radial flow, v theta will be 0. So where we have to focus? We have to focus Vr. What is the Vr? Just now we have seen it is q upon 2 pi r, and it's nothing but 1 by r dou psi by dou theta. If you check r cancel out, what you will have? It's a dou psi by dou theta is equal to q upon 2 pi. R cancel out, okay, both side. What is the d psi then? You can write d psi is nothing but q upon 2 pi into d theta. See, dou psi by dou theta is equal to q upon 2 pi, or you can write d psi is equal to q upon 2 pi d theta. Now it's very clear. If you integrate this, so what you will have? You will have a psi is equal to, as I told you, once you integrate, then constant of integration will come. Okay, so I told you I am writing the final result. Mathematical, all the steps are not required, so directly I can result. So constant of integration, again it will becomes 0. Again it becomes 0. So that part I am skipping, and directly I am writing d psi. Once you integrate psi, q upon 2 pi, and once you integrate d theta, it will be theta. So your final stream function value is nothing but psi is equal to q upon 2 pi by theta. If you check 2 pi is nothing but constant. What is the psi? Psi is nothing but theta. Okay, psi is nothing but theta. What is the mean of it? It's very clear. It's very clear. If you go for the pattern of this uh, streamline, because stream function now you got, and if you go for the pattern of streamline, so how you will get it? Because we are talking about the source flow, so I can say this is the source flow now here, and see, these are the source.
Sir,
Theta will be in radian, correct? Theta will be in radian. Always remember, today I will tell you, and also I already told, if theta is with the trigonometric function, means theta is with sine or with cos, with tan, with cot, cosec. These are the trigonometric function. If theta is with the trigonometric function, then always theta will be in degree. But if theta is without trigonometric function, so everywhere, if theta is without trigonometric function, then theta will be considered as a radians value. Always remember here. Okay. All right. Now, so with different value of, because here psi is directly proportional to theta, you got, this is the psi, and psi is nothing but q upon 2 pi into theta. So psi is basically directly proportional to theta. So with different value of psi, you can, first I will draw it. Okay, right. So now if you want to show the streamline, so obviously this is the streamlines, without any doubt. But what is the value of theta? I am considering theta here. Any angle you can take, clockwise or anti-clockwise, just say this is what theta. Okay, if you are measuring angle in this way, so this will be the theta is equal to 0. So obviously this is nothing but psi is equal to 0. If I say, I don't know, I'm not measuring this, but I can say this is, suppose, just for example, this is nothing but theta is equal to 45 degrees. So convert this 45 degree into radians, it will be pi by 4. No? Pi by 4. Yes, pi by 4. Then what will be the psi? Psi is nothing but, so psi is nothing but, what will be the psi? Check. Psi is q by 2 pi into theta. In radian, I have taken pi by 4. So it becomes what?
my
Q by 8, right? So this is the psi q by 8. Similarly here also, it's your choice up to what numbers you can take. But here see, this theta is nothing but 90 degree. If you convert in radian, it's a pi by 2. So for pi by 2, what is the psi now? Pi by 2. So it's q by 4, right? Q by 4. Similarly others also you can. So this is what is streamlines. As you know, for the streamline we have a direction. We have direction. This is the streamline. All right. So for the source flow or for the sink flow, the stream function will have a radial lines, will have a streamlines, and that will be radially outward if it is source, and if it is sink then it will be radially inward, that will be the streamline. But what will be the potential line for in case of source? What will be the potential line or equipotential line? It will be circle. Now if superimpose this both for the source flow, okay, for the source flow, if you want to superimpose, so this is what source flow. Now check clearly. For this source flow, this is now streamline, okay. Just now you have seen the stream function. So stream function is what? Showing radially outward, that is the source flow. Just now you have seen this is the stream function. All right, here you have seen this is what psi is equal to 0, this is what psi is equal to, just now you have calculated, it's a q by 8, it's a q by 8. Here it's a psi is equal to q by 2, like that. That value you can calculate continuously if you are interested. Now if I want to show the potential function, equipotential line, so where I will show the equipotential line, it will be circle, and for each and every point, if you see the equipotential lines, it is cutting to the streamline orthogonally. Orthogonally means perpendicular. This is what equipotential line. This is what equipotential line, right? This is what equipotential. So here equipotential lines are circle, but streamlines are straight lines, radial lines, and it is going outward. Always remember, streamlines will have a direction, so we'll show by the arrow, but equipotential line don't have any direction, as already I have explained why will not have a direction for the equipotential line, that also already discussed. So this is what phi 1, this is what phi 2, this is what phi 3, and here this is what psi 1, this is what psi 2, and this is what psi 3. This is all about source flow. As I told you, for the sink flow, we are not going to derive anything. Directly you can write the result. What is the result for sink flow? Sink flow. First, you should know what is the velocity for the sink flow. Okay, so each and everything you need to write for the sink flow also. Obviously, we'll have a VR, that is radial velocity, and it will be minus q upon 2 pi r. Generally, what is the VR, radial velocity? That radial velocity will be q upon 2 pi r. You have proved it, no? Just now you have proved. See, q upon 2 pi r. That is nothing but radial velocity here. See, this one you have proved. This is q upon 2 pi r, that is radial velocity. So positive will be for the source and negative will be for the sink. Here I have written. So this radial velocity minus q upon 2 pi r will be the radial velocity. And what is the tangential velocity for the sink? Obviously it will be 0, because source and sink both are radial flow only. So for radial flow there is no tangential velocity. So tangential velocity, always remember for this also, it's 0. This is one. Second point, what is the equation of potential function? Equation of potential function phi. What is the phi? Just now you have calculated q upon 2 pi. Oh, sorry. Q upon 2 pi ln r, right? So for the sink flow, it will be minus q upon 2 pi ln r. Third point. What is the third point? Equation of stream function. What is the stream function? Just now you have proved it was q upon 2 pi theta. That is the equation of stream function, but here because it's a sink, so it's a minus sign. All right. Anyway, now coming to the pattern, how to show the presentation of the potential line, equipotential line, and streamline. So it's very clear. If you want to draw the equipotential line, so because here it's a circle, so there is no issue, you can draw directly. But generally what we'll try to do, for the first you will draw the streamline, and for a streamline, for the sink flow will be inward, right? Will be inward, just like this, because it's a sink flow, so all the streamlines will go inward. You already have proved. This is the psi value, so it's minus q upon 2 pi. So minus sign is indicating just opposite, and obviously it's a sink, so obviously that flow will be inward. This is the inward flow now, like this. These are the streamlines. Okay, how to draw the equipotential lines? So equipotential line and streamlines both are orthogonal, so you can draw perpendicular, something like this, something like, right. This is what psi not, this is what psi 1, this is what psi 2. Similarly here, this is the phi 1, this is the phi 2, this is what phi 3, something like this you can draw. All right, this is for sink flow. So this is the graphical representation of sink flow, and obviously these are the equipotential line. There should not be any doubt. These are the equipotential lines, and these are the streamlines. Streamline and for the sink flow, and similarly here also this is what streamline. Always remember, and this is nothing but equipotential line. So for the source flow or sink flow, the equipotential line will be circle. So this is what equipotential line. Equipotential. So mathematical model for the source flow and graphical representation also for the source and sink, both clearly it is explained, done.